When we talk about space as a forcing factor for innovation, Mars is that use case where you cannot resupply. And this is a 3-year mission. How do you manage your inventory? How do you create what you need during that mission and sustain health during that time?
Hey, Carl, how's it going?
Pretty good, Iram. How was the eclipse?
Oh my gosh, total eclipse of the heart. Although we didn't get the total eclipse here in New York, we got 92%. So we didn't get the total blackout, but it did feel like dusk a little bit and got colder. But what a fun time. You were hanging out together with some of our friends in the biotech space. We were at the Brooklyn Botanical Gardens. I was really surprised of the turnout.
Well, so there's not going to be another eclipse like that up for 20 years. And just to kind of paint a picture, the Brooklyn Botanical Gardens is next to Brooklyn's biggest park, which is Prospect Park. And so it's basically like in the center of Brooklyn. It's a beautiful place. They had a eclipse viewing event. It sold out. The lines were very long. Even though if you looked around, you could see a lot of people. It didn't feel that crowded, probably because the Botanic Garden is very large. And it was really good, like you said, to see all the people that were out to experience this event. It's occasional in a lifetime. And we were lucky because even though it was overcast, the sun and the moon kept peeking out from behind the clouds. We got some good pictures. And everyone had their Warby Parker branded eclipse viewing glasses. But Iram, you brought some great glasses that you had bought beforehand that really made the viewing experience that much better. So thank you for doing that.
I can't take credit for that. Our friends that also joined us went on Amazon and bought them in advance because they're enthusiasts. And I mean, there's people that chase eclipses. It'll be 20 years for New Yorkers to see a full eclipse, but you can see it probably in other places in the world from now until 20 years, right?
Right. I'm sure. Yeah. No,
Yeah.
I mean, these things happen. They're celestial events. It's like Halley's Comet. Every 80 years or whatever, eclipses happen fairly regularly. But it was fun. And you know what else was fun was the feedback we got from our episode about networking.
Yeah, that networking episode, we received some feedback from people saying it was a bit different from usual because it's just you and I chatting about some real world experiences that we have when we go to events, when we meet people, especially when we meet people that are trying to break into the industry or they are first time in the business world coming out of the lab and wanting to share their company and meet people and sell. It's interesting to see how they approach it. I'm very empathetic to people, whether they just say, hi, this is my company. Are you interested? Without even asking me a question. I still want to learn, but there are some stories that get a little bit crazy. And if you really want to hear those stories, please listen to our episode on networking. It's episode 70. If you want to laugh, I think that's the one to listen to.
Well, and I think the feedback was good. We should do more episodes like that where it's just the two of us talking. Last night we were at another event, and one of the things that we were asked is if we were going to do a list of companies that should be founded based on ideas that we see. And I think we should do it as an episode here because we keep a constant list of ideas and evolving those ideas. I think Y Combinator is famous for having done that, companies that they were looking for founders for. I think we should just do the list because we see a lot of that.
Yeah. And I would just say about the ideas, I mean, they're not ideas that we just see. These are ideas that you and I come up with because we have vast exposure to different types of technologies and business models and thinking because, of course, we're talking to people on the pod. We have a great episode in store for you guys today. And then also from our day-to-day work. So we start seeing patterns. And then we come up with these ideas like there should be a company that does X for Y. Like and people are like, wow, that's a great idea. And then I'm like, okay, well,
we're not going to do it, but we'll give it away. So if someone's out there wants to do it, just make sure you give us some founder shares.
Yeah, exactly. Just like there's a lot of ideas out there. Ideas are easy. Execution is hard. We had an idea for a podcast. It was so like, okay, we rolled up our sleeves. We're like, all right, here's a plan. And we did it. And we've been doing it for over a year now, 72 episodes in. So very, very, very happy about that. But if you can do it, you can do it. That's the motivational quote for the day.
You can do it.
But yeah, Events aplenty, networking aplenty. I went to another DSci NYC event last week. I recommend people looking into DSci. We have interviewed Albert Annis of Valley DAO. We have some other episodes coming up where we talk to people that are in the DSci DAO space, focusing on different types of missions. There'll be an episode released in a few weeks with Laura Mankini of Athena DAO. But the DSci event was insane. It was during NFT NYC week. We had quite the crazy crowd in terms of people with different interests, different ages, different backgrounds, especially in New York City. And DSci NYC, I say we because it actually is started by Michael Fisher, and he really wants to create a self-governing, self-operational community. He's also even issued DSci NYC tokens for people that help grow the community. So I'm sure I'll get some tokens just by mentioning it on the pod.
Airdrop.
Airdrop, boop, airdrop. Yeah, exactly. That's what these, and I'm new to this. So like a lot of these kids are like 20 years younger than me. And they're like, oh, yay, are you going to airdrop some tokens? And I'm like, what airdrop? You mean like, do I need to turn my airdrop on my iPhone? Is that how that works?
You need to have a wallet rum.
Oh, geez, Carl, you are an expert. We'll definitely have to talk more about that. But yeah, you do need to get a wallet. Besides that, this event, insane, had the CEO of Prophetic AI. I will put a link in the show notes. And what they have done is created a device that looks like a halo that you wear to induce lucid dreaming. And there has been a lot of research that has come along where the founders incorporate that into a device, into something that hopefully works. They haven't actually used it yet as of this recording, but I know that it's going to happen soon where they're going to do a neural stimulation where they're actually going to create the lucid dream. So I'm sure by the time you guys hear this, there will be some more information on it. But ultimately, they use transcranial focused ultrasound, which is a technology that's all the rage in neuroscience in terms of influencing your brain. A lot of science and research coming out of Elon Musk's Neuralink, and there's been a lot of activity on that front. And it was really interesting to learn about the approach, the mission and vision of the CEO, talking about how lucid dreams have created a lot of profound innovation and ideas from the dawn of human existence when we were dreaming. I mean, he talked about prophets and the way that they described what they've seen and their dreams and their sleep. And lucid dreams are when you actually have more control over an experience. So it does feel very real. So when people say that they have heard from God or they've had some experience, it's something that they might have experienced for real through a lucid dream. And there has been a lot of big thinking that has happened in lucid dreams, like mathematical equations that were solved and the meaning of zero. And there's a lot that can happen. So if we can,
benzene.
Yes, the structure of benzene was mentioned as well. It came through a lucid dream. So it could be another alternative for therapy, for positive thinking, for experience. The founders also from the world of AI creators, but then they think of the next level AI, that there can be a takeoff event, and AI is obviously going to be replacing a lot of jobs. So what does that mean? Does it create more experiences for people? As long as people are being fed and can have some money coming in, then sure, yeah, we all want some great experiences and have a party. So it's just very interesting to talk to people in this world that have lots of money and want to do fun stuff and they're promoting AI. And then the other conversation also goes to like, what about the people that need some more knowledge if they weren't working in white collar jobs, that need to make sure they increase their salaries? That's another conversation. But yes, it is full on. We're going to be lucid dreaming. What are we all going to learn?
Yeah. So in contrast to the very serious NYC NFT event that you went to, I got invited to like a clothing drop event that was at a new clothing company called 9cc. I think they've been around for a while. But I'd been invited by Armin Zadakbar, who's the president of the Web3 organization in the EU. So that was also very interesting, not as deep as what you did. There was a lot of people looking at clothes, buying clothes, talking about NFTs. The whole city was crawling with people who are focused in the NFT space. And I was watching it in real time on Warpcaster, where I've started to establish a presence, which I have said is a good place for the DSci folks because it's a lot of Web3 people. X, formerly known as Twitter, and Warpcast are the places where these people congregate. So I've been playing around a little bit with Warpcast and trying to promote the podcast on there and just see what kind of traction we can get. And whether that becomes a channel for us remains to be seen. There's a lot going on out there.
Yes. So one other thing I want to say about this whole world of DeSci, Web3, DAOs, and again, keep talking about it, how do we apply it to research? How do we apply it to biology? How do we apply it to exploration and discovery? So yes, we are talking about it. Carl and I are out there learning and trying to make those connections and trying to bring people that are doing it, not just the DeSci technology part of it, but the application part of it. So we want to bring it to you guys so that you guys can learn about alternative ways of doing research, starting companies, getting your ideas out there, creating a community. That is what this is about. That's what this podcast is about. Very, very fun times, but also making sure that we all take time to chill out, relax, and have a good time. But, and when it comes to exploration, one of the things that we always want to talk about is space, and whether it's space companies that are building things or what we're watching on TV. So For All Mankind, there's a lot of other shows, there's movies. And on a recent family movie night, we were just sitting watching Super Mario Brothers. And it's so interesting to see how they talk about space and galaxies as where like Princess Toadstool, Peaches is from a different galaxy. Mario is from our world. The Mario Brothers talk about space, and the pipes are how they travel. Those pipes are like wormholes to other galaxies. But I thought there was a very amazing quote that Princess Toadstool or Peaches said. And she said, there's a huge universe out there with lots of galaxies. When Mario was just talking about, oh, you're like me. She's like, no, there's a lot going on out there and we need to learn. And this is what we are excited to talk to Elizabeth Reynolds about. We had a great conversation with her. She's on the forefront of space technology, what people's missions are, whether it's getting out to space and the mechanical engineering of things or the biomanufacturing part of things, which I'm very excited about. I love the fact that you've met her, you've known her. How did you first meet Elizabeth Reynolds?
We were on a panel together in Long Beach at a Blue Biotech event, Blue Biotech meaning ocean biotech. And this was a couple years ago. The event was put on by Ignite, which is a accelerator that focuses on ocean biotechnology. And so Elizabeth and I were on a panel talking about different forms of biotech. Then last year, you saw her speaking at SymBioBeta. I was not able to attend that panel, but I did run into her a couple times. And then last November, when I was in DC for this event to present biotech products to Congress, I happened to run into Elizabeth at the airport. It was just a random meeting. We caught up with each other and then went our separate ways on different flights. And we talked about getting her on the podcast. So lo and behold, here's Elizabeth Reynolds. All right, Elizabeth Reynolds, we are so thrilled to have you here today on Grow Everything. We've been trying to get you on for a really long time. We're so excited.
I'm happy to be here.
You have such an interesting background. You've done stuff in biotech, medtech, mobility, interactive companies, and now you're doing space-related work, which fulfills this intersection that we're interested in. Again, you know more than I am, space and biotech. But can you give us your background and how you got into the aerospace industry?
Absolutely. It's funny. My path has been extremely not linear, which in most industries today isn't particularly unusual. But in the aerospace sector, people tend to follow a very standard path into the industry. People start as engineers, they excel and advance within the company, come into leadership positions, and that's the path. I have had a very unusual background. Formerly, I studied bio. I studied developmental bio, the effects of hormones on heart development in alligators, which is super applicable in the world, I have to say. But I transitioned out of lab and into the business world about 15 years ago. And I spent a lot of time working with traditional companies to help them expand, whether that was new locations, international expansion, and then transitioned into the startup world probably about 10 years ago now. I primarily have been the hired adult as COO for those companies. And yes, I've worked across a large number of industries. And this has been more a product of me being a mission driven person and saying yes to things that really excite me and wanting to try new things. When I left my last COO role, I took some time to kind of reassess what I wanted to do. And I really just wanted to spend all day working with entrepreneurs, but perhaps not as an executive in a startup anymore. I started talking to a lot of different accelerators, venture funds, trying to find a place that was a good fit and find something that would capitalize on the breadth of experiences in my background. And instead, I fell absolutely in love with everything that is happening in the aerospace industry today and dove headfirst into things with Starburst. So learning yet another new industry. But one of my great joys over the last 2 years has been really building our practice at this intersection of space and biology. The Starburst is broadly an innovation enabler for the aerospace industry. We work with government entities, large corporates, NASA, DoD, big aerospace primes of the world to help people understand emerging technologies and innovation. Historically, we've worked across every aspect of that industry, from things like quantum sensors to supersonic jets, but we've done everything except for human flight and some of the biological research opportunities in space. That's where I have spent a lot of my time over the last 2 years.
Wow, that's amazing. Elizabeth, I'm so happy that you're on our podcast. As Carl mentioned, that I nerd out on space. I've asked space-related questions to our other guests to see how they think about their companies and innovations in relation to space in general. But I would love to know a little bit more about the work that Starburst is doing to support bioinnovation. You did just say that maybe not the studies that are biostudies in space, but how are you working in this intersection at Starburst when it comes to space and biology? And what is the connection between space and biology?
So I'll start with that second question first, because I think when most people think about points of intersection, space and bio is not something that they're thinking about at all. And there's a lot of overlap. The most obvious, of course, being just human bodies in space. It's an extremely harsh environment. Microgravity and radiation in particular affect every single system in our body. There's really direct application to understanding how to keep humans healthy in space, to maintain their health, maintain a level of performance so that missions are successful. Then we can look at the scientific side of it, which is that when you remove gravity as a consideration, you actually can learn a lot about how different molecules interact, how our cells express their genes. So there's a lot of fundamental research that can come out of this environment that holds the promise to really advance a lot of important research here on Earth as well. We also can talk about what we need for long-range missions. And this is where I think we get into a lot of the really fun stuff with synthetic bio is when we think about the fact that we have to either bring, find, or make everything we need for these missions. The answer is that we have to make a lot of things. So we need new means to not only do research, but to actually manufacture a lot of different materials from foods to pharmaceuticals.
What you're saying is just a reminder of how much work we have to do and how little we know. One of the things that I often think about when watching a space show, Star Trek or The Expanse, I just think about the amount of infrastructure that needs to get built for us to move into the stars, if we can say it that way, into the solar system. And we're not going anywhere without biology. So tell us more about Starburst contributing to that progress.
Historically, the only people who've been looking at this work that needs to be done have really been NASA, some of the other space agencies. I mean, that's pretty much it. So as we come into the modern era, we have the opportunity to really capitalize on what's happening in the commercial market. A lot of what we focus on at Starburst is supporting entrepreneurs who are building solutions that are applicable for both government customers and the commercial market, because the needs are often very different. When we look at what's happening in biology in general today, in the bioeconomy, we see just an amazing rate of development. Even looking at synthetic bio kind of broadly, it was niche 10 years ago. We're moving towards a scale and an industrialization that's really going to change a lot of our everyday existence. We need to tap into some of that to solve these problems that we have in space today. We need to prioritize solutions that have both space and terrestrial application because we need to support commercially viable companies that can continue to grow and develop and build new solutions at a really rapid rate because we're behind. If we as humans want to go to space, we do have a lot of work to do. So by tapping into some of the momentum that we see in the startup world today, and tapping into some of the potential as we start really looking at things like AI being implemented into biological processes, we have a much better chance of being successful. So we are really working with entrepreneurs to try to help them understand both what's needed by NASA today to sustain these longer range missions, what we need for the commercial industry to be able to support dozens of people in space, hundreds of people in space at a time from diverse backgrounds with pre-existing conditions as we develop out the low Earth economy.
There's a big controversy that happens when people talk about space exploration and investing in space. The big controversy that, oh, why aren't you investing in the problems we have here on Earth? And the conversation is, yes, we are developing innovations for space, but they have applications here on Earth. We're doing both because when you're in space, you have very different parameters, like you were talking about how biology works differently, gravity is constricting. So you could learn something new by exploring science and technology in space. So to that extent, have you seen in recent history, or like maybe in the past few years, any technologies that were designed for space but now has applications here on Earth? Can you share some of those stories?
There are hundreds of examples of that. The truth is that we're all utilizing space every day, all day. If we think about our phones, that is the primary example. Internet and GPS are part of our everyday lives today in a way that it never has been before. Most of the use in space today is still really focused on communication. That's the majority of it. We do see a much greater interconnectedness in the world today. The advantages that come with being able to bring connectivity to really remote areas are significant from a social population perspective. The other thing that we've seen a lot of in recent years is Earth observation. I don't think people realize how far that technology has come in recent years, but we have near real-time monitoring capabilities over a lot of the Earth. We can track individual trees. We can look at pests on those trees, track ecosystem health, all from space. The majority of data that we use to monitor and manage climate change comes from space and can only come from space. But when we start looking over the next handful of years, we start seeing a lot more opportunity for some of this research and for manufacturing. And we're starting to see this on the satellite side when we see some of these satellites that are being developed to allow for research to be done on board, research that can be done without a human being in that process. If you just need to see samples, go into space and collect that data, you can do that today in a way that is cheaper and easier than you have ever been able to do so before. And as we start looking at the ISS retiring and being replaced by these commercial space stations.
ISS stands for International Space Station, which many of you know, of course. And it serves as a multifaceted platform for scientific research and technology testing that's done in a unique microgravity environment. And it's international because it's a collaboration between multiple countries, including the United States, Russia, Europe, Japan, and Canada. And fun fact, as of this recording, it has been orbiting Earth for over 25 years with over 270 astronauts having traveled there. And specifically, the ISS travels in low Earth orbit, which is abbreviated as LEO for short, and we will talk about things going on in LEO in a bit.
We suddenly have a lot more functionality when we talk again about the research and manufacturing side of space. So in some ways, this as a potential, as an economy, is something that's new and that we're going to see develop over the next 10 years.
When you talk about these private space stations that will be going up in the next decade or so, are they going to be, and I don't follow this close enough, right? You guys will make fun of me because I don't know this, but will we be shipping the materials for building these from Earth via SpaceX, or is any of the materials going to be manufactured on site?
In the long run, it will be both. For now, we need to ship things. And Axiom, who's one of the private space station providers, will be building off of the ISS. But the ISS is old and needs to be replaced. But in the long run, absolutely being able to manufacture hardware and being able to build from LEO is the most efficient thing. It's the most sustainable thing. There's a lot of material already in space. There is a lot of space debris today. And there's some really exciting research being done looking at how to not only collect and manage some of the debris, but recycle it and reuse some of that material.
I was just about to comment on the space debris. I ran a fellows program in India 10 years ago, and one of the fellows were looking into space debris. So I ended up learning a lot about that. And I'm just curious, you mentioned research, but are there any projects underway in the space debris program?
Yeah, most of the research is still being funded today by NASA, but there are a lot of startups that are approaching this from many, many different angles. The biggest issue is just that it costs money to go and capture these objects. It's extremely complex, but this is something that internationally people are tracking quite closely today. And there's still a lot of questions about it. You know, when we talk about the environmental management piece, we don't really know what the long-term effects are even of deorbiting all of these things. And so we're definitely looking for creative solutions.
Space debris, does it travel very fast? I mean, I'm just trying to wrap my head around
very fast.
Yeah, very fast. How would you capture it and connect it? Or is there a robot that goes out there or someone with a big baseball mitts just catching the space debris?
Yes, really. In different formats, you have to align with that object. So if that object is moving at a certain rate or spinning at a certain rate, to be able to make any sort of contact with it, you have to be moving in the same way. And so that's where a lot of the complexity comes in, is just how do you come up next to this object, which could vary wildly in size and shape and trajectory. How do you come up close to it? How do you establish contact, and what do you do? And there are people who are working on solutions that look a little more broadly like a way to catch something, like a catcher's mitt. I've seen solutions that are almost more vacuum-like, and how do you deal with some of the small debris? Because this is one of the things that I think is non-intuitive, is that the speed of these objects is so fast that even debris that is really, really small can be moving fast. You have to punch a hole in a satellite, in a space station, in a human. We're pretty good at maneuvering. So we don't actually have a lot of collisions in space, but as we continue to send more and more objects into orbit, this becomes of greater concern.
And I'm under the impression that the majority of the items that are in space are actually these smaller things that are probably under a kilo in weight. Is that correct?
Yeah, many of them are. There are many large objects too, though. There's a really wonderful company called Privateer that is working to really democratize access to space. And you can go onto their platform and really actually look at what is above your head and look at what satellites are there, what junk is there, understand where all of it comes from, who left it there, and how much it would be to manage that debris.
If it's okay, I'd love to switch gears and talk about manufacturing in space, which is something that I am incredibly curious about. So you're talking about a lot of different companies. I'm curious how many of them are related to manufacturing in space, and if any of them are using biology to manufacture in space at this point.
So there have been thousands of experiments done in space today, but most of what has been done in space is research. We really haven't seen manufacturing in space yet today. A lot of that capability, again, will really come with these commercial space stations, commercial LEO destinations, CLDs, as we call them in the industry, because that's part of the capacity that they're building in. While the ISS today has really extensive equipment, there's a dedicated laboratory there to facilitate this research for the US and for other countries. It's research-based, and most scientists are uncomfortable stating any sort of conclusion from them because the sample size is so small. There are a lot of people working to address this today. Some of the satellite options have the potential to facilitate manufacturing in space, whether that be biological or semiconductors. We really are looking for more development here and more companies who are interested in doing this.
Yeah, I'm really interested to know of the research. And I know they're very small numbers, small ends, but I'm curious to know like what research is the most promising or what you're excited about. Because at SynBio Beta last year, they had a space biomanufacturing track, and I went to all of those. There was a panel that was talking about biomanufacturing, talking about manufacturing pharmaceutical drugs and obviously algae and other microbes for eating or for clean the space or actually provide oxygen, create like an ecosystem within the spaceship, I guess. But I'm just curious from your perspective, what research is most promising to you? What's going to be the first thing to excite us?
I'll answer that from the commercial perspective first, because at the heart of what I'm doing with the work with Starburst is trying to support commercial growth in the sector, because this is part of what really drives momentum. What we know the most about today are really crystals. What we know about crystals in space is that they grow in a more uniform fashion. They're larger, they're more pure, which really leads to more effective drug discovery and development. And there's been a lot of work done there. And this is a lot of the work that some of the bigger pharmaceutical companies are doing today. We're starting to see some interesting developments, which are all very early, but some really interesting potential looking at things like treatments for cancer that are coming out of some of the work that's being done in space today. There's also a lot of interest on the bioengineering side. So stem cells in particular are interesting and a near term potential area of growth. When stem cells are cultured in space, because gravity doesn't have the same force, they are able to grow in kind of a 3D form, and they maintain their stemminess for a longer period of time. So they don't start to differentiate. And so you can get a much larger batch of applicable stem cells when they're cultured in space, as opposed to when they're cultured on Earth, which has the potential to significantly increase the efficacy of different therapeutics. Those are a couple of the things that are really near term. Again, I think on the research side, some of the regenerative medicine stuff is the most exciting. There's some contention around this particular phrasing, but when you look at the effects on the human body in space, in many ways it mimics the effects of aging. The stresses that are put on the body, the stresses that are put on cells, have a similar effect. So in some ways allows you to study things in a condensed amount of time. And you can study some of the effects anyways of different treatments of different diseases. It's not that space is an exact analog for aging, but it does offer us some of those same insights. In some of the same ways, it allows us to study some of these effects in what are effectively healthy humans, because when people come back from space, these effects begin to normalize and they return to a healthy state. And so there's a lot of potential on a cellular level, on a system level, to really better understand how we disease, how we age, and develop therapeutics for that.
Do you know if any experiments have been done for using biology to manufacture materials in space?
Certainly looking at different components. We've studied microbes in space a fair amount. Microbiomes in space are different. Kate Rubins has actually done a fair amount of research on this. But again, we're still learning more. The same effects that influence the way we produce individual materials are, of course, going to affect us on a system level. We know biofilms grow thicker in space. There's a lot of potential there. And I think certainly when we talk about food, when we talk about pharmaceuticals, when we talk about new material production, when we talk again about the availability of resources, the need to recycle what we already have, all of this ties in.
And so you also mentioned that the space exploration industry isn't very big. So you mentioned NASA, there's some private players, but can you talk a little bit more about the ecosystem and how Starburst Aerospace fosters collaboration between all of the stakeholders within your ecosystem?
Yeah, so the aerospace industry generally has been a lot more insular than other industries. And so what we see is a lot of this being driven by governments, a lot of work being contracted out as large programs, large systems. And so a limited number of companies have been able to participate in that ecosystem to win those contracts to do that work. And that's changed pretty rapidly over the last 10 years. And we see an entire new generation of entrepreneurs coming in. How we got our start and a lot of the work that we still do today really centers on helping to align different stakeholders in the industry to more clearly define needs, to understand emerging technologies and define strategy around those. We do a lot to try to help people even just speak the same language, as simple as that sounds. But we can see it in conversations where we talk about points of intersection between industries like bio and space. We see the same level of miscommunication when we're talking about commercial industry and government as well. Everybody has their own language, their own way of looking at problems, talking about problems, and it doesn't always translate. It's sometimes really difficult to understand what is really needed in the industry and where there are opportunities to enter, where there are opportunities to innovate. Our goal is to really help advance new technologies and help actually drive them into market so that we continue to keep a competitive edge.
Hi, a quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business.
You're based in Southern California. I know you travel all the time. We had a hard time booking you because of your crazy travel schedule. But what do you see as some of the unique opportunities and challenges that are faced by people interested in entering the market in the United States?
The US is an amazing opportunity. No matter where we look at aerospace, whether we're talking about the more traditional defense applications or whether we're talking about NASA, whether we're looking at some of these new points of intersection, the US government is the biggest customer. And so there's a huge amount of funding for initial research to support some of these bigger projects. Organizations like DARPA, who are funding a lot of moonshot projects that are looking for solutions that are 10, 20 years out. That's an opportunity that just doesn't exist in a lot of other places. We also just have an extraordinary amount of private capital here. When we look at what's happening in the entrepreneurial sector in aerospace broadly, about half of the really large companies of the unicorns in the sector are in California. That's this intersection of large legacy industry players, of government funding, of private capital funding, and the existing startup ecosystem that you really need to support development. There are certainly challenges. I mean, the US is not necessarily very collaborative with other countries. And so it can be really difficult to communicate about things that do have national security implication. The opportunities more than outweigh the challenges of working in this ecosystem, and it's where everybody wants to be.
That's really amazing. One of the things I was thinking of as you were talking, so you have NASA, you have private companies, you have SpaceX, Blue Origin, you have Virgin Galactic, and then you have a lot of startups that are participating in Starburst Aerospace. Can you talk about how they collaborate specifically, like maybe a project that they've worked on, and you don't have to say who did what, but like maybe take us through a journey of how there's a collaboration happening?
I mean, we see it all the time. We see it between companies in our accelerator cohorts. I think this is part of what is allowing the rapid growth today is that the industry is more mature. There are not only just early stage kind of pre-seed companies, there are these giant multinational corporations in the government. There's everything in between. Biology faces many of the same challenges looking at the aerospace industry. It's extremely expensive and you need a lot of access to specialized resources, specialized testing equipment, specialized environments to test whatever technology you're building in a real world environment, access to space. And that first contract, that first opportunity to really prove that your technology will do what you've said it is going to do is one of the biggest challenges in development. more mature startups, companies that are at like a series A or beyond that are already operating in the market are much more likely to partner and engage with these early stage companies that may be adopting a specific widget. The startup has developed a piece, like one simple piece of a component system, and they say, if you put this in, it'll make the system more efficient. Will you try this? Or it may be a completely new service. It may be a new model of rocket engine. It varies quite a bit, but it is the collaboration between these different players that really drives everything. Because for the larger companies, the more mature startups, their ability to interface with these big multinational corporations is part of what allows them to get access to the larger contracts. We see a lot of collaboration, and we need to see more collaboration to continue to support the economy.
Correct me if I'm wrong, it just seems like Starburst is really a facilitator in that capacity.
Yeah, that's a lot of what we do. And on that mission to accelerate the rate of technology adoption in the market, that's one of the big hurdles. So we spend a lot of time trying to facilitate those engagements. At this point, we've been operating for about 12 years. And so we have a pretty robust network and are able to really help facilitate some of those introductions between not only startups and industry, but between startups to help facilitate some of that growth.
And tell us a little bit more. Your focus is being a managing director at Starburst. What else are you doing to foster these kinds of collaborations?
We operate in a lot of different ways. So we work directly with entrepreneurs, we work with universities, we work with the government, we work with corporations. A lot of that, again, is really focused on aligning interests and helping people to understand what the opportunities are in the market. As the market generally begins to shift and we see some of the pressures that come with this really rapid rate of technology development by hardware standards, rapid rate of technology development, there's a strategic advantage to incorporating these new technologies. And even for those companies who are able to develop everything in-house, who have really amazing teams of scientists, people in the entrepreneurial community may be doing it faster. And if you are not one of the first ones to market, it just doesn't matter anymore. We run a lot of startup programs, and a lot of these are with partners like NASA. We'll help entrepreneurs kind of navigate the market, help them raise capital, help them define their product market fit, meet with potential corporate customers, and those sorts of activities.
A lot of space agencies have been going to the moon in recent years. So the US just went. I'm curious to know if any of the startups worked with that mission and how.
We actually just saw something really amazing happen in the industry, which is the first private company landed on the moon.
Oh, geez,
so
wow.
This was...
Why isn't this in the news?
It was.
You heard it here first, a lot of people.
In case you missed it.
Yeah, in case you missed it.
So there's certainly been a lot of increased interest in the moon. And so we've seen other countries do this. India just successfully had a lander on the moon. Intuitive Machines, which is a private company, one of the more mature stage startups, was one of the awardees of some NASA funding to do this mission to the moon. And so they just successfully landed on the moon last week.
So back to Iram's question, were any Starburst portfolio companies involved in this moon landing?
Sadly, Intuitive Machines is not one of our companies.
What's exciting in your world in the next few months?
As I mentioned, I've been spending a lot of time at this intersection of space and bio, and I'm really excited that we'll be launching a new program, probably will have already launched by the time this podcast airs, supporting some of these needs that NASA has to leave orbit and continue to explore further in space. So we're working with NASA's Human Research Program and at Baylor's Translational Research Institute of Space Health to put together a new program that supports biotech, biomed entrepreneurs coming in to help solve some of these problems. And so our goal is to really reach a new audience and to continue to bring new people into the space ecosystem. And we'll be looking very broadly at what it takes to sustain crew health, mission health in this environment, from future medical systems, autonomous medical systems, to the sensors, the devices that input that, to the production of pharmaceuticals and therapeutics on the back end. We're working with Microsoft on this as well.
That's amazing. Okay, so that's like the near term. What has you excited in the longer term, in 5, 10 years?
In 10 years, we will see commercial space stations. And I'm really excited about that because it does begin to really unlock space as an economy in a new way. Obviously, again, there's a really robust economy there on the communication side, on the imaging side. But when we start utilizing the full potential of space from researching and manufacturing potential, that is what will unlock that. I'm also excited for the return to Mars. That may not be within that time window, but that is happening. And when we talk about space as a forcing factor for innovation, Mars is that use case where you cannot resupply. And this is a 3-year mission. How do you manage your inventory? How do you create what you need during that mission and sustain health during that time?
This is a manned mission to Mars?
Yeah.
That's already on the books for NASA, right?
Yep. This is certainly on SpaceX as well. And Jeff Bezos with Blue has talked about Mars quite extensively. So I suspect we will see a lot of activity.
Wow. That's amazing. Why are we towards the end of this conversation? We should have started up with Mars because there's so much to talk about. Terraformation, for example. Is there any companies that you've seen that are exploring that for Mars? But obviously there are applications here on Earth because there's a lot of barren land on Earth from extracting and agriculture, extractive practices. Anything you've seen on the terraformation side? I throw that question out there.
I love what Interstellar Lab is doing. They're one of our portfolio companies. What Barbara has built is a biopod. She's building space first, but it's an advanced closed loop system that allows plants to be grown in a controlled environment in a way that encourages the expression of specific properties. And so for plants that are being grown for specific nutrition or specific pharmaceutical application, these biopods allow you to get the most out of what you are growing and to grow really rare and high valuable plants in any environment. This has been developed for space, but is being used here on Earth for both pharmaceutical and for beauty application as well. The cosmetics industry is another area that's really interested in some of these unique and high value plants.
Wow. Yeah, that's Mars. Are we going to go underground? Are we staying on top of the surface in special pods? What do you think?
What I think there's a near term and there's a longer term, but it'll probably be a little of both. But we're a ways away from being able to truly terraform a planet. But when we look at the scale of challenges that we face with climate change here on Earth, when we talk about environmental management, when we talk about that in space, it's to an entirely new level, whether that be terraforming, whether that be managing the controlled environment on a space station. When we talk about scrubbing CO2 from the atmosphere, these are core technologies that are developed, that are continuing to be developed for space, that also have application here.
And mining asteroids, anything on that front?
That's probably a ways off still, although certainly it's interesting. And again, when we talk needing materials in space, that is a very good source of materials.
I was asking the more biomanufacturing question earlier because in my mind, I want to know, is it going to be cheaper to be capturing asteroids or pulling rocks off of the moon to build materials or grow them on site? And I'm sure those calculations have been done.
It'll probably be a combination of both. And the truth is that we don't know all those answers yet today, though we can produce almost everything that we need today from a biological source. A lot of that hasn't been proven at an industrial scale either. And again, what that really looks like in space is an unknown.
Yeah. And then I know this would be a hard question to answer, but looking at the universe of space companies that you've seen, are there any that you particularly admire or you've really been inspired by?
In this industry, I have to say, I am inspired every day by the people that I meet. I've never worked somewhere where there's so much passion for making a better future. And I think that is really a product of some of the long timelines and some of the collaborative nature of this industry. It's rare to meet people who are working today on projects that they might not get to see finished. And the timelines of the work that's being done in this industry, it breeds an optimism and a level of collaboration that you just don't see other places. I really love, I've mentioned them before, but I love these research satellites. I think it's a really interesting way to look at things. Outpost Space, which is another one of our portfolio companies, is approaching this with a sustainability first mission, which I really love, and building returnable, reusable satellites, which when we start to look at the 10x increase in satellite launches that we're expecting over the coming years, being able to reuse those is not only important just from a return of sample perspective, but from a material use perspective, from a sustainability perspective. And they're one of the only companies I know that is strongly promoting that message.
The atmosphere has multiple layers, and there's a temperature inversion that happens, which is the weird thing about the atmosphere. At the top of that temperature inversion, there is life. There is a biology there. So basically, there's a microbiome there that has not yet been studied. Am I correct in that, or am I imagining that that's true?
I've not heard of this. It does not mean that you are not correct, but I don't know.
I'm often wrong, listeners. Just let me know.
There's a microbiome across the whole atmosphere, though. Maybe there's a special microbiome in that section you're talking about, Carl, but
Could be.
the microbiomes are in different cloud formations. I was talking to someone about that the other day. So cloud microbiomes. That's the next pod.
Yeah. Elizabeth, I want to be very, very mindful of your time. We really appreciate this. Was there anything that we should have covered that we didn't?
Aliens. We didn't talk about aliens. Extraterrestrial life. I shouldn't say aliens. That's a slang word.
The Fermi paradox could be its own podcast for sure. Yes.
We'll put a pin on that.
Yeah.
Can we have you back on maybe in a few months after the program launches, as the mission to Mars gets developed? I'm sure you guys get a front seat into the planning of that. I would love to continue this conversation.
Yeah.
Well, yeah, same here. And for me, it's about the materials. I mean, I obsess on the whole space elevator tether thing, which is the materials problem, which I'm fascinated by. Will you be at Symbio Beta this year?
I will be. Yep. I'm on my continued mission to bring space to the bio community. I will absolutely be there.
That's great. Well, we'll look forward to seeing you there. But thank you so much, Elizabeth. I really appreciate it. And yeah, we want to have you back. I mean, this has just been such a great conversation.
My pleasure. And thank you guys for having me.
Elizabeth Reynolds is amazing.
Yes, I just wanted to talk to her forever. We really started picking up on a lot of questions that just come to mind. She answers one question that leads to another question. This is how rabbit holes start, but she's doing it. I mean, this isn't just theory. She's meeting all these companies, learning more about how we can travel to space and imagine living in space. And it requires very fantastical thinking. And she's collecting those brains. I mean, what a great mission that she's on. No pun intended. She is on a mission for missions. And I just loved speaking with her.
Yeah, I think we're going to see her again at Symbio Beta in May. I think she'll be speaking there. It's like one of those examples of someone where the conversation is just getting warmed up and we should just have her come back. She lives on the cutting edge, and I think a lot of people are really interested in that.
Yeah, I mean, and also just meeting the companies that she's working with, that her group's investing in and supporting, whether they're startups from people that are just working on products to support space travel and space exploration, or astronauts. It would be so great to have Kate Rubins on the pod. She was at Symbio Beta last year. Kate Rubins has a background in biology. She does lead some of the biology research that happens in space. So it would be great to talk to her because she's living it. One of the things that I do love talking about is terraformation. So the concept of terraforming other planets, but also be able to think of it to terraform other planets, but bring it to Earth, because we do have 11 billion square miles of barren land on Earth. So there's a whole opportunity to revitalize our planet. I don't think that's a stretch of thinking. We know that we have this extractive capitalistic operation and system here on Earth, especially in the Western world. So how do we revitalize that land through the concepts of terraformation that we can learn through space exploration and thinking of how to do it on Mars. I think that's a very interesting sub-genre of space exploration.
Right. It's also funny, like just the way the universe works. Elizabeth mentioned Chris Mason. I've known of Chris for a long time. I think 2 hours after we recorded the podcast, we went to this Symbio Beta event in New York City and walked in, and there's Chris Mason. And we're like, hey, we just talked to Elizabeth Reynolds. She said we should talk to you. Chris was like, oh, yeah, I know you guys. Why don't we know each other? So then it started into this whole conversation. But I'd love to get Chris on it as well, Chris on the podcast, because Chris talks about how biology needs to change to withstand the challenge of space.
Is he an astronaut, scientist, biologist?
So he is a researcher at Cornell Weill. He is famous for having developed the microbiome of the New York City subway. He swabs things in the subway and got a lot of news a few years ago when his research was published, and he found some very interesting organisms in the New York City subway. But Chris has written a book called The Next 500 Years, which is really about space travel and how humanity has to evolve to be able to withstand the challenges of space. So Chris, if you're listening, we want to get you on. But yeah, I think this whole area of space fits very nicely with, for sure, climate tech and also with what we're doing in biotech.
Yeah, absolutely. I just think it's a great way of thinking of putting parameters on things, because on Earth, there's a lot going on, but it's just good to say, like, all right, if you're in zero gravity or if you have this and that, and it's a new way of thinking, and I really appreciate it. And of course, a vision of the future of being able to visit different celestial bodies, whether it's the moon, whether it's Mars, or I don't know if there's an asteroid that will be coming around that we can lasso and use for for mining. I don't know. I mean, there's so much out there, and it's exciting to see what we can do. But of course, there's a lot here to do on Earth. So a lot of knowledge sharing between what's going on in space and what's going on Earth is super important. So stay tuned for more space talk here on not what's our friend Neil deGrasse Tyson Star Talk. This is not Star Talk, you guys. This is still the Grow Everything podcast. But I will say Neil deGrasse Tyson has been having a lot of biotech people on the Star Talk podcast. So Neil deGrasse Tyson, if you're listening, I would say stay in your lane, but you've been doing a great job, and we'll be talking about space as well. And if you want to come on our podcast, that'd be great.
Okay, so by the time this podcast airs, you will have traveled. I will maybe have traveled. I know for sure I'll have gone to Ginkgo Ferment, so I'll report on that in a couple of episodes. Probably the episode will air before we go to Symbio Beta. And if you're planning on going to Symbio Beta, don't have your ticket yet, you can get a $300 discount if you use the code Grow Everything. So we look forward to seeing you there.
Yep. And don't forget to leave us a review or contact us for any questions, any guest recommendations. All that information is in the show notes. I hope you guys are having a great day. You guys are doing well, and stay tuned for the next episode.